Hello, we are beginning our Unit 7, which is Intro to Algebra and Equations, and this lesson is on one-step addition and subtraction equations, so make sure you have your packet or label your notes page accordingly. When we solve equations, we need to use inverse operations, which you'll see in a moment here. So it's important for you to write down and recognize that addition and subtraction are inverses of each other, which means they're opposite, and multiplication and division are inverses of each other. So you might want to pause and write that down. And then here's the steps for solving one-step equations, which will make more sense in a second when we do them together. But if you want to pause, I know it seems like a lot, but pause and write all of these steps down as well, because these are going to be super important for you to have to look back on. Write the equation, draw your slide or train tracks, use the inverse operation, which we just talked about, solve for the variable, check, and then circle. And then something else that is super important that you want to write and circle: whatever you do to one side of an equation, you must do to the other side to have the sides remain equal, which is kind of like when we're finding a common denominator of a fraction. Remember, whatever we do to the bottom, we have to do to the top. So let's do some equations together and talk about the steps. So I would say to write down all the ones that I do on the video, you do in your notebook, and then when it's the you tries, you for sure do them and then check as well. The more you do in your notebook, the better practice you have and the more it will stick. So x plus 6 equals 4. So our first step is to draw our train tracks, which is what we call, or a slide. So what we do is we draw a line on both sides of the equal sign, and that separates the left side from the right side. So we can see that here we have x plus 6 and here we have 4. So something plus 6 has to equal 4. So I know that if I take the opposite, so we said inverse operations so the inverse operation of addition is subtraction. So if I subtract 6 on this side, remember, whatever we do to one side, we have to do to the opposite or to the other side. And I do the same over here. That's going to keep it balanced, because if I'm taking 6 away on the left side, I need to take 6 away on the right side. I also know that something plus 6 equals 4. If I just do the opposite, 4 minus 6, it would get me to x. So let's do that. Notice I wrote it nice and neat right underneath the number, even though that right side got a little big. I'm going to draw a line to separate that, and then I'm going to do the operation. So x stays the same because I'm taking the 6 away from the 6. 6 minus 6 is 0, so we would have x plus 0, and then 4 minus 6 equals negative 2. So x plus 0 equals negative 2, which is really the same as x equals negative 2. Before I circle that and confirm that that's my answer, I'm going to check it. And what I'm going to do is I'm going to go back to my original equation, but I'm going to put a negative 2 in for x. So negative 2 plus 6 equals 4. And I ask myself, does that work? Yes, it works. So then x equals negative 2. Let's do another one together. Y plus 9 equals 22. So I draw my slide, and then the inverse of 9 is subtraction, or the inverse of adding 9 is subtraction, or the opposite of adding 9 is subtracting 9. And really what we're doing is whatever we can do to get the variable alone. And I know that if I do 9 minus 9, I get 0, so that gets me y alone. So if I'm adding 9, then I'm going to have y plus 18, and that really doesn't help me. I want to get y alone so I can figure out what y is to make the equation true. And then 22 minus 9 is 13. And then I'm going to put that back in. Does 13 plus 9 equal 22? Yes, it does. So y equals 13. Let's do one more together, and then you can pause and do some on your own. So my slide always goes on both sides of the equation. This time my variable is on the right side. So I always look for the side with the variable. G plus 6 equals negative 5. So if I subtract 6, which is the opposite, notice I'm doing whatever is being done to the variable on whatever side it's on. I do the same thing over here. 6 minus 6 is 0. And so G stays the same. Negative 5 minus 6 is negative 11. And then let's check that. Negative 5 equals negative 11 plus 6, and that does work. So then I like to rewrite it with the variable on the left side, G equals negative 11. Okay, pause me and do these next three on your own. Okay, so then if you want to check and make sure you got the same answers, for the first one, I subtracted 4 on both sides, so I got m equals 11. I know for some of them it seems silly to go back and check it, but I promise you it pays off, because when it gets harder, then you'll know exactly how to check it and to make sure that it's right. And if you check it and it's wrong, like it doesn't equal both on the like the left to the right, then you know that you accidentally maybe added when you were supposed to subtract, or vice versa, or did the wrong number. And then that's awesome, because then you know right away that it's wrong and you can go back and retry it. For 5 plus h equals negative 7, h equals negative 12. And then for negative 3 equals f plus 4, f equals negative 7. So then for subtraction, same thing. I would say to write down as many of these as you can. All of them would be the most practice, but it's basically the exact same steps, except we are going to do the opposite. So this time we're subtracting. So x minus 2 equals 1. I do my slide or my train tracks for every single problem. You're going to be doing this for the next few weeks for sure. X minus 2 equals 1. My variable is on this side, which means I'm going to do the opposite of subtracting 2, which is adding 2. And then I can see negative 2 plus 2 is 0. That's why we're doing the opposite. We get x alone. X equals 3. And then let's go back and check. 3 minus 2 equals 1. And when I'm doing this, I'm not just writing it out and just checking it off like, yep, it works. I'm actually checking to see, does 3 minus 2 equal 1? And yes, it does. So then remember, my answer is this right up here, because my answer is whatever x equals, whatever number is going to make the equation true. Y minus 3 equals 4. So the opposite of subtracting 3 is adding 3. Do that on both sides. I like to draw an x there just so I know that that cancels out and I have y left. Y equals 7. And then we do 7 minus 3 equals 4. Yep, 7 minus 3 does equal 4. So then y equals 7. And then I have negative 8 equals g minus 6. Remember, oh, my variable is over here. So now I'm going to look on that side. And I look at whatever is being done to the variable and I do the opposite. So the opposite of subtracting 6 is adding 6. Both sides, line it up nice and neat. G equals negative 8 plus 6 would be negative 2. And then negative 8 equals negative 2 minus 6. Notice that I'm putting that negative 2 in for G right there, and I'm redoing that equation. Negative 8 equals negative 2 minus 6. Yes, that works. So G equals negative 2. Pause me again and do the rest of these problems on your own, and then come back and check. All right, then here's what I have. M equals negative 5 for the first one. H equals 1 for the second one. F equals negative 14. If you got any of them wrong, I'm sorry that it's a little sloppy, but you could pause and check my work and see where you made a mistake. Lastly, the lifespan of a black bear is 3 years longer than the lifespan of a zebra. Write an addition equation that you could use to find the lifespan of a zebra if the bear is 12. So we know that however long the zebra is, the bear is 3 years longer. So my equation, I'm going to use Z for zebra. So a zebra, add 3, and then you get the lifespan of the bear, which is 12. And then, so we want to know always how to write an equation also. But then what we do is we solve it with our train tracks. We do the opposite. So the variable's on the left side and it's being added to, or 3 is being added to it. So the opposite then would be subtracting 3. We do that on both sides. Z equals 9, and then I can check 9 plus 3 equals 12. I ran out of room over there. So the zebra's lifespan would be 9 if the black bear's lifespan is 12. That's all I have for you for this video. So keep these notes handy and have a great day.